So now we're going to move on to this Taylor series, and the setup for the Taylor series is, it looks like this. So it's f of x equals f of a plus f prime of a times x minus a plus f double prime of a x minus a, or first derivative raised to the first power. This is the second derivative of x at a raised to the second power all over 2 factorial plus f to the third, taking the derivative 3 times, to the x minus a third power all over 3 prime. And you can kind of see that there's a pattern here. So here, that's really 1 factorial, which is just 1. So that's why I kind of left it off before. So what the pattern is whatever order you are, you take the derivative that many times, and then you multiply that by x minus a raised to that order. So this is in order of 1, this is in order of 2, and this is in order of 3. And then it goes to f to the n power, taking the derivative n times, to the x minus a raised to the n power all over n factorial. So whatever order, say you need a 5th order, you would just plug in 5 for n, and that would give you that term. So here it says find the Taylor series for the function f of x equals ln x about x equals 1. So the about x equals 1, that is your a value. So here, this is your a value. So wherever you see a, that's where you plug in your 1. And so first I'm going to take the derivative. I'm going to give it 4 terms because I'll give it a good, so then you can see the pattern. So let's have, so f of x equals ln x. So when I take the first derivative of ln x, I get 1 over x. Sorry, can you see that? There you go. When I take the second derivative of ln x, so I'm taking the derivative of the f prime of x, I get negative 1 over x squared. And so I'm just going to do this a few times so then I can plug it into the equation. So this becomes 2x to the third power. And I think I'm going to do it just one more time, just so that I can get a good pattern going here. This would be negative 2 times 3 all over x to the 4th. And yeah, so here, yeah, sorry, never mind. Ignore me for that. So now I'm just going to plug in, because x equals 1 is my a value. 1 is also the a value. So now I'm going to plug in f of a, which is f of 1, and plug that in. So ln of 1 is equal to 0. And I'm just plugging in a for each derivative. So f prime of 1 is equal to 1 over 1, because it's 1 over x, and that's just 1. The second derivative of 1 is negative 1 over 1 squared, which is negative 1. And the third derivative would be 2 over 1 to the third, which is just 2. And the fourth derivative would be, of 1, would be negative 2 times 3 all over 1 to the 4th, which is negative 6. Okay, so now I'm going to plug it into my equation up here. So I get f of x, which is my ln x, this power, or this series, is equal to f of a, which we showed was 0, plus f prime of a, which is 1, times x minus a, so x minus 1, plus the second derivative, which is negative 1, times x minus 1 squared, and don't forget the 2 factorial over there. So plus the third derivative, which is 2, times x minus 1 raised to the third power, and then your third factorial, plus 4, or f to the fourth derivative, derivative taken 4 times, so that's negative 6 times x minus 1 raised to the 4th power, all over 4 factorial. So when you clean this up, you get x minus 1 minus x minus 1 to the 2nd power all over 2 factorial, plus 2 times x minus 1 to the 3rd power all over, so 3 factorial is 3 times 2 times 1. Oh, I guess in 2 factorial is 2 times 1. Minus 6 times x minus 1 to the 4th power, all over 4 times 3 times 2 times 1. Okay, so here there's a pattern going on. So when you took the derivative, I'm just going to go back to the derivative up here. This was x to the negative 1. So when you took the derivative, you did 1, you brought like the 1 out, so you got the negative 1, x to the negative 2 power, which is this right here. And then when you got to the third derivative, you kept that negative 1 is just a constant. So it was negative 1 times negative 2, bringing the negative, doing the power rule here. And then this is the x to the negative 3 power. And when you go to the fourth derivative, you keep those constants. You bring down that negative 3 and you make it x to the negative 4 power. So you can kind of see a pattern forming here. How this is, like here it's 1 and then it's 1 times 2 and 1 times 2 times 3. So do you agree that this 1 times 2 times 3 is the same as 3 factorial? And this right here, 1 times 2, is 2 factorial. So you can, down here, where you take the third derivative, instead of having 2, this would be 2 factorial. And this 6 right here would actually be 3 factorial. It's still negative. So when you have 3 factorial up here, this 3 times 2 times 1 is the same thing as 3 factorial. So those cross out and you get x minus 1 to the 4th over 4. And the same here, you have 2 factorial, which is the same down here. So when you're in the third order for this given series, it's x minus 1 raised to the third over 3, which is because the 2 factorials cancel out. So a way to show this series in shorthand would be, or just to put it in terms of n, it would be, because it's alternating, we have this negative 1, and it is x minus 1 raised to the n power. So like when it was fourth order, it was 4 raised to the 4. When it was third order, it was raised to the third. And so that's why it's the n there, all over n factorial. And so when it's raised to the third power or the first power, it's odd, and then it's positive. So you know that in order to get a positive 1, this n has to be, it would have to be raised to an even number. So here I'm going to have n minus 1 as my, so then I can get like an even power. So when I put in 3, I get this raised to the third power, and oh sorry, there's no factorial there. This is raised to the third power over 3, and when I put in 3 for n here, I would get 2, and that's a positive one, so it's that same term. So here is the Taylor series. Here it is, and then it would go plus dot 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 negative 1 to the n minus 1 times x minus 1 to the n all over n. Okay? So that is your Taylor series right there. Okay, so last problem. It's really similar to the Taylor series. It's called Maclaurin series. I'm sorry if I say that wrong. It is the same as, it's the same format as the Taylor series, this kind of function here, but instead, wherever there's an a, it's equal to 0. So that's the special case for this type of series. So I put page 430 in the corner because if you have the 12th edition, that's the one that I have, there's a list of common Maclaurin series. So that's just maybe a good reference point or a good study page to look at to maybe memorize those for the AP test. So here I'm going to do the same thing that I did for the Taylor series, for the problem before, how I took the derivative. So I'm going to do that so then I can plug it in to the equation. So for f of x is equal to e of x. So when I take the derivative of that, I get e to the x. And I'll do 4 terms just to keep that going there. So you can kind of see a pattern whenever you take the derivative of e to the x. No matter how many times you take the derivative, you get e to the x also. So I could take this f to the n amount of times, and I'm still going to get e to the x. No matter what my n is, I'm going to get e to the x as the derivative. So now when I plug in 0 for f of x, e to the 0 is just 1. So now when I do that for the derivatives also, I get 1, and so you can assume, because all the derivatives are the same, you're going to have the same point when you plug in 0. So whatever n is, so when you take the derivative n times. It could be any n, it could be 2, it could be 3, it could be a million, whatever n. You're going to get e to the 0, which is 1. So plugging this back to that equation for the Taylor series, which this is just a special case of. So f of x is equal to, here I'll write it out real quick, okay, so I think the last video got cut off, so I'm just going to finish this problem real quick. So f of a, I'm just writing the equation, x minus a plus f double prime of a over 2 factorial times x minus a squared, and that just goes on to the n of a, n factorial times x minus a raised to the n. So because e to the x has the same derivative going down, oh sorry, and then a is your 0. So wherever there's an a, that's just going to be 0. So when I plug in f of 0, we have 1 plus, so just be careful, just because it says 0 doesn't mean all the terms 0 out. You still have to evaluate it. So when you have f prime of 0, it's going to be 1 times x minus a, and your a is also 0, plus f double prime of 0, which is 1 over 2 factorial, times x minus a squared, plus 1 over 3 factorial x cubed, and this goes on until you have 1 over n factorial x to the n.